Laws of logarithm. Logarithms. The logarithm of a number to the base 10 is the power to which 10 must be raised to give the number. Example 1. I. Log 1000 to the base 10 is equal to log 10 raised to power 3 to the base 10, which is also equal to 3 because log 10 to the base 10 is 1. 2. I. Log 1 over 100 to the base 10 is still equal to log 10 raised to power minus 2 to the base 10, which will give us minus 2 because log 10 to the base 10 is 1. It is equals to minus 2. I. Log 10 square root of 10 to the base 10 is equal to log 10 raised to power half to the base 10, which is giving us log half, which will give us half. To every logarithm equation, there is a corresponding index equation. Example 2. I. Log 1000 to the base 10 is give us log 10 raised to power 3 to the base 10, which will give us 3. As we have said, log 10 to the base 10 is 1. Therefore, which will give us 3. Then 1000 is equals to 10 raised to power 3 according to our law of indices. I. Log 10 raised to power s to the base 10 is equals to y. Then s is equals to 10 raised to power y. The base 10 is the most familiar because 10 is our accepted unit for counting, and logarithm to this base are most helpful in arithmetic calculations. Logarithm, however, may be found to any base. The logarithm of s to base a is written as log s to base x a. The logarithm of x to base a is written as log x to base a. If the base is not given, it is understood to be 10. The logarithm of a number to the base a is the number to which a must be raised to give the number. For example, if log s to the base a is equal to y, then a raised to power y is equal to s. When a number is expressed as a power of a, its logarithm to the base a is equal to the index. Example 3. We are asked to get log a raised to power 3 to the base a, which is now equals to 3 because log of the same base and arithmetic, or the law of the same base with the logarithm is 1. Therefore, the log of a to the base a is 3. I. Log square root of a to the base a is equals to half because square root is a raised to power half. Therefore, a is equals to log square root of a to the base a is equals to half. I. Log 8 to the base 2. We know that 8 is 2 times 2 times 2, that is 2 raised to power 3. Therefore, log 2 raised to power 3 to the base 2 is equal to 3 because log to the logarithm arithmetic 2 is the same thing with the base 2, which give us 1. IV log 5 3 times square root of 5 will give us, we know that the log 3 square root of 5 is the same thing as 5 raised to power 3 over 2, which is equals to, which will give us 3 over 2, because log 5 to the base 5 is 1. Formula connecting logarithm. There are 3 formulas which are true for logarithm to any base and which corresponds to the 3 in this formula already given. Log s to the base a plus log y to the base a is equals to log xy to the base a. This is your equation 4. Log s to the base a minus log y to the base a is equals to log x over y to the base a. This is our equation 5. Log s raised to power n to base a is equals to n log s to the base a. This is our equation 6. They are proof for the corresponding index formula in the following. Let log s base a equals to u and log y to base a equals to v. Then s is equals to a raised to power u and y is equals to a raised to power v. Therefore, xy is equals to a raised to power u times a raised to power v, which is equals to a raised to power u plus v. So log xy raised to the base a is equals to u plus v, which is equals to log x raised to the base a plus log y to the base a. This is our equation 4. Proof of equation 4. Also, x over y is equals to a raised to power u over a raised to power v. This is equals to the same thing as a raised to power u minus v. Therefore, log s times x over y is equal to u minus v, which is equal to log x to the base a minus log y to the base a. This is proof for equation 5. Again, x raised to power n is equals to, in bracket, a raised to power u closing bracket raised to power n is equals to a raised to power un. Therefore, our log x raised to power n the base a is equals to, is the same thing as un. Therefore, if the n raised to power, if log x raised to power n going to the back of the log, we will now have n log x to the power to the base a. This is our equation 4. The first of this formula tells us how to add logarithm. For example, log 2 plus log 5 is equals to log in bracket 2 times bracket 5, which is equals to log 10, which is 1, and log 9 to the base 12 plus log 16 to the base 12. Two of them having the same base, we now multiply each other to have log 9 times in bracket times 16 in bracket to the base 12, which is equals to log 144 to the base 12.